Hey, it's Miss Hurst again. Did you miss me? Well, Miss White and I are here to do sections 1.4 and 1.5 today. I'm doing section 1.4.
And I'm doing 1.5.
All right, but first, I get to go. 1.4, measuring and classifying angles. First, let's talk about what is an angle. Well, an angle is made up of two different rays, which we talked about in section 1.2, and they have the same endpoint. Now, we're not necessarily talking about opposite rays. They can go in an angle kind of like this, all right? Well, we're going to talk about three different ways on how to name an angle. Notice that there are different letters down here. We have A, we have V, we have B, we have a number 1. Well, first, before we name this angle, let's talk about the parts of it. If I drag this little A out here, we're talking about from V to A, this was V down here, remember, is a side. We've got one more side to this angle, and we've got that going from V to B. Okay, so we've got our two rays, and then we've got this guy V, which we'll slide back over here, as our vertex. So each angle, like I said, is made up of two sides and a vertex, the ray with a common endpoint. All right, so now that we figured that out, by a single letter is one way that we can name the angle. That single letter has to be the vertex, and that vertex, remember, is that middle point, the common endpoint. So I could say that this is angle V. All right? Now, we could also say, we could use the names of a point from one side, the point from the vertex, and a point from the other side. Well, the point from one side was A, the vertex V, the other side B. So I could say that this is angle A, V, B. Now, you're more than welcome to go the other direction, angle B, V, A, but those are the only two ways that we can name this particular angle because V, the vertex, has to be the middle letter, okay? Now, the last way that you can name an angle, and this is the only option if numbers are available, is that you can use the number that denotes it. So I could say that this is angle 1, okay? So, before we get to the chart that I just showed you, I skipped a part, we're going to go down and we're going to do some examples in practice. So go ahead and pause this, draw the pictures, see if you can name all of the sides, see if you can name the vertex that goes with all three angles that are in this picture. And yes, there are three. And then you can name all three angles so that they are distinguished. So I'm not concerned about, oh, which one? Did you mean the top small one? Did you mean the big one? Be specific. All right, so did you come up with M as your vertex for all three angles? I hope you did. If not, please come in with questions tomorrow. Now, all of the sides, we're talking about rays. All of the sides have the vertex as their endpoint, so they're all going to start with M. So the first one is from M through N. So I'm going to call the first side MN. Okay? The second side goes M through point O. So I'm going to call that guy MO. And there's one more side, M through P. So we're going to call that MP. Notice that I am using the ray notation. Now, I want to be very specific about all three angles. I cannot just say that we're talking about angle M, because then you would say which one, right? So we're not going to say angle M. We're going to either go with the numbers, angle 1 or angle 2, or we're going to use three letters to name these. All right, so my first angle, I'm going to start with the largest angle. So that's going from here, outlining in red right now on your screen. And I can name that angle N. N is my vertex, and he goes in the middle, P. Right? Or we could have done it backwards, angle P, M, N, but M has to be in the middle. All right, the other two angles, I could either say angle 1, and that's the same thing as angle, if we're talking about angle 1, let me change colors here. We're talking about this angle right here. So we could say that would be angle OMP. So these are the same. Now, if I want to talk about angle 2, I could also call that angle NMO. Okay? So again, make sure that vertex is the center letter. All right, now take a second, copy this chart down, pay attention to the measurements because we're going to be recognizing these in examples that are going to help us set up equations. Once you finish writing this down, I would highlight this last part, that a straight angle has exactly 180 degrees, and that a right angle has exactly 90 degrees. Okay? So, do you remember what was that segment addition postulate we used in section 1.3? Well, think about it for a second and then see if you can guess what the angle addition postulate is. Have you guessed yet? Okay. Well, here's my angle. Here's the angle addition postulate. So, dealing with this picture, if P is in the interior, meaning it's somewhere inside the angle, then the measure of angle RST is equal to the sum of the measures of angle 1 and angle 2. In other words, part plus part is equal to the whole thing. Same exact equation from segment addition postulate, but now we're talking about angles. All right, so to clear that up, the measure of angle RST is equal to the measure of angle 1 plus the measure of angle 2. Well, let's go ahead and put this into action. All right, here's my picture. Angle RST is my whole angle. And I've got two parts to this. I've got part 1 and I've got part 2. All right. So given that the whole angle is 145 degrees, so again, this whole thing is 145. We want to find the measure of angle RSP and the measure of angle PST. They didn't ask us to solve for x, but I still have to do that in order to make this happen. So we're going to set up our equation. Part plus part equals the whole thing. So here we go. All right, 2x plus 10 plus 4x minus 3 is equal to 145. Okay, I'm going to kind of go a little bit quicker through my algebra here. So combine your like terms, move things around, and we end up with 6x plus 7 is equal to 145. I'm going to subtract 7 from both sides. 6x is equal to 138. We're going to divide by 6. We get x equals, give me a second, still working,
23.
Thank you, Miss White. Okay, so we've got that x equals 23, but again, Miss White told you before, we have to read. This is not our answer. We need to plug it back in. All right, so angle RSP. Which angle is RSP? Well, let's find it. Here's R, here's S, here's P. So we must be talking about this angle right here. So the measure of angle RSP, which I'm going to denote with an M in front of it, is equal to 2 times our value of x plus 10. Okay, so we're going to end up with 56 as our final measure. Two parts to this though. I need to find the measure of angle PST. So PST, that's P, S, and T, that's the other part. All right. I could plug it back into x, or I could do 145 minus the 56. Okay. The final answer here, the measure of angle PST, is equal to 89. Okay. So I'm going to give you a chance to practice. First thing you need to do is classify the angle. And what I mean by that is decide, is it acute? Is it right? Is it obtuse? Or is it straight? And then remember those measurements that we associated with that. If it was right, it made it 90 degrees. If it was straight, it was 180. So I'm going to drag these two questions out, give you guys a chance to try them on your own, and then we'll see how our answers compare. Okay. All right, so hopefully you've had a good chance to solve those. You're feeling confident. Number 1, this is a straight angle, so that means its measure is 180. So I know that part plus part is equal to 180 in this picture. So 10x minus 5 plus 4x plus 3 is 180. I'm going to combine my like terms. 14x, negative 5 and 3 gives me negative 2 is 180. 14x equals 182. And x
13
equals 13. Okay? So this time it does just say solve for x. So I don't need to plug it back in. I don't need to find anything else, but we totally could if they asked us to, right? All right. So let's solve the next one. The next one, we said this was a right angle. Fantastic, and it is 90 degrees. So that means part plus part is going to equal 90. So here we go. 2x plus 2 plus x plus 1 equals 90. All right, so 3x plus 3 equals 90. So 3x equals 87, and x equals 29. Miss White's helping me out in the background because, you know, this is mental math and I can do it, but you don't want to wait for me to do that. Okay, so x equals 29, and again, it just asked us to solve for x, so we're done. Okay. All right, one more thing. We talked about congruent segments in section 1.3. Now we're going to talk about congruent angles. Two or more angles with the same measure. So again, we're dealing with measure equals segments are congruent, measures are equal, angles are congruent. Okay. Now here's how you mark the angles congruent. I know that this angle, which we're going to call angle A, and this one B, okay, are congruent if they both have the same single arc mark, or they might both have two arc marks. Okay, if they have the same markings, they're considered congruent. Okay, now again, just to summarize, angle measures are equal, numbers are equal to numbers, and angles are congruent, meaning I'm actually talking about the physical shape of those. And again, we're using that equal sign with the squiggly over top of it, or tilde. All right, so one more thing. This is a pretty lengthy section, so we'll give you a breather, take a pause after section 1.4 is over. Angle bisector. Have you ever ridden a bicycle? I have. It has how many wheels? 2. So a bisector cuts things into 2 pieces. And what it does is cuts them into 2 equal pieces. It's a ray, so it goes from an end point and extends on, and it divides it into 2 angles that are congruent. So I know that this angle here is congruent to this angle here. The interior space is exactly the same. Now in this particular problem, they've told us that ray BD is an angle bisector of the angle ABC, and that the entire angle ABC is 82 degrees. Well, if the whole thing is 82 degrees and it's got 2 equal parts, then the measure of angle ABD, which is ABD, this top angle here, is going to be half of the whole thing. So my answer is 41, or 41 degrees. Okay, makes sense? All right, try this problem on your own. Okay. It's not necessarily a right angle, it's not a straight angle, so we don't know that. The only thing they tell us is bisect, so think about what that means. Okay, go ahead and pause now and figure it out. All right, so we want to find the measure of angle ABC. ABC is the whole thing. Well, if this is a bisector, then the angles are congruent. So 5x minus 11 equals 4x plus 1. So we're going to subtract 4x, and I get x minus 11 is equal to 1. We're going to take that 11 to the other side, and we get x equals 12. Again, did that answer my question? No, I want to find the whole angle. So I'm going to plug this back in to one of these guys. I like positives better, so I'm going to pick 4x plus 1. So 4 times 12 plus 1 gives me 48 plus 1, or 49. So that's only half of it. That's the measure of angle DBC. I don't want to know DBC, I want to know the whole thing, so I'm going to take this and I'm going to double it. So the measure of angle ABC is twice as big, or 98 degrees. All right, take a breather, pause it if you need to, take your bathroom break, what have you, go eat dinner, and here we go, section 1.5.
Thank you, Mrs. Hurst. That was great. So we're going to still talk about angles, so that's why we put these 2 sections together. But now we're going to specifically talk about some angle pairs. A pair meaning 2 angles. Okay, we have specific names. So we have complementary, supplementary, and adjacent angles. Let's look at complementary angles. They are two angles, just like I said, a pair, but they're angles who sum 90 degrees. So for complementary, the main number that you have to remember is 90 degrees, which you guys just saw last section talking about right angles equaling 90. Well, these are two angles that equal 90. Supplementary is very similar, and supplementary is a word that you're going to see over and over and over in geometry, and you're going to know it like the back of your hand. It's two angles who sum 180 degrees. We've already talked and seen about 180 being a straight angle, okay, or a straight line. So they're two angles that are supplementary. Last one is called adjacent. You might have heard the term adjacent before, just not in math, but adjacent kind of means next to or touching. So when you have adjacent angles, they share something that's in common, the vertex and the side. So remember from Mrs. Hurst, okay, the vertex is that center part. Well, it's going to share a same side in the middle. Okay, so this is a common vertex, common side. These two angles, 1 and 2, are both adjacent because they share something together. So let's practice some of these in looking at some diagrams on the next slide. Go ahead and see if you can match each description with its picture. So, adjacent supplements. Adjacent means next to, touching, and supplements mean 180. So this would be an example of adjacent supplements. Adjacent complements mean touching, and 90 degrees is this picture. And finally, the non-adjacent ones, non-adjacent supplements, if they were connected, they would definitely form a straight line or 180. And the non-adjacent complements are the two here that aren't touching, but their sum of the angles could equal 90 degrees. I'm moving ahead of myself. Let's do some examples and some word problems. So I'm going to go ahead and scroll these out if you want to pause it and see if you can figure out these three on your own before we go through it. If not, just follow along with me as I go through these three examples. The first one says angle 1 is complement of angle 2. And the measure of angle 2 is 8. Find the measure of angle 1. I always tell you to think of it, equation where you have these two numbers and then the words tell you what it's set equal to. Well, complement means 90. So we're trying to find angle 1. We have angle 2 to equal 8. And angle 1 I'm just going to mark as an x because that's what we're going to find. So 8 plus x equals 90. That should be our equation to solve for the measure of angle 2. So now solve the equation, you subtract from 90, so you get x to equal 82. Or the measure of angle 1 equals 82 degrees. Okay, the second one says angle 3 is supplement to angle 4, and angle 3 is 117. Okay, so supplement means you have two angles that add up to give you 180 now. It tells you that 3 is 117, and I'm just going to put an x for the measure of 4. Okay, so when we add up 117 plus x, set it equal to 180, solve that equation, you get x to equal 63. So the measure of angle 4 is equal to 63 degrees. The last one has some variables setting up more of an equation where it gives you the two angles are complementary. So now we're still going to do the 90 degrees, but now we just have some more x's. So LMN, the 4x minus 2 plus PQR, the 9x plus 1 should add up to give you 90 degrees. This one is just solving for x, so we'll go ahead and do the algebra problem. If you can do it on your own, then go ahead and do it on your own. 13x, okay, combine the like terms. Minus 2 plus 1 is a minus 1 equals 90. So 13x, add the 1, gives you 91. X is equal to 7. And we're done. Okay? Moving right along. The next two are terms that you're going to see in different shapes, especially triangles. You might see them in circles throughout the semester. So these two you will see and use fairly often. First one is a linear pair. Now, within the word linear pair, you see the word line. We're still talking about pairs of angles, so both of these are two angles. And this is what a linear pair is in words. And actually, what it is, what it looks like in example form is like so. Okay, because it's two angles that are adjacent, so like we talked, they have to be touching. All right, and they form a straight line. So linear pair is 180 because they're adjacent and supplementary. So we know 180 for a straight line, and that's what a linear pair is. The second word is vertical angles, second term. And they're talking about pairs, and it's in this crisscrossing intersection that kind of looks like an X, okay? Vertical angles have more of a technical definition that's kind of hard to see. It says their sides form two pairs of opposite rays. They look like a cross, and they're not adjacent. So I'm just going to put numbers within the angles so I can show you what they look like on the actual diagram, because they're non-adjacent. Well, we know 1 and 2 are actually a linear pair, okay, from this diagram. So we do have linear pairs in the diagram, and actually you can find other linear pairs within here. Angle 2 plus angle 4 equals 180. We also have angle 3 plus angle 4, oops, forgot the angle sign, equals 180. And then there's one other linear pair, angle 1 plus angle 3 equals 180. So we have those linear pairs within this diagram, but let's talk about the vertical then. Since they're not adjacent, they don't share a common vertex or side. They look like a cross. So really, when you look at this, angle 1 and angle 4 are across from each other. They actually have, if I outline angle 1, the opposite ray on that side is here, and the opposite ray here is there, so angle 1 and angle 4. And actually, I just put those congruent marks because angle 1 is going to be equal to angle 4. The measures, measures are equal. So measure of angle 1 is equal to the measure of angle 4 because they're vertical. There is one other pair, angle 2 and angle 3 are vertical angles. They're across from each other. Okay, and they're also, I'm putting 2 arcs because they are congruent to each other. So the measure of angle 1 is equal to the measure of angle 3. 2. Did I just mark? Yeah. Thanks, Ms. Hurst. 2 and 3. My mistake. All right, so let's take a look at some vertical angles and some examples with this. Here's the first one. Go ahead and draw out that diagram and see if you can list out all the pairs of vertical angles. I'm just going to write them in parentheses. Hopefully you got angle 1 and angle 4 vertical, angle 6 and angle 3 vertical, and angle 2 and angle 5 vertical. Those are the 3 pairs of vertical angles in that diagram. Okay, second question, second example here. Move it down, go ahead and draw it out. And now we're not using the numbers, they're naming an angle with 3 letters. So we need to identify the angle. It says which angles would form a linear pair with angle B, A, D. So it's this angle here. Remember, a linear pair, okay, forms a straight line. So what I tend to do is I take one side of the angle, so ray AB, and I'm going to extend it to form a straight line. So now that I look at this angle right here in the red that I've just outlined, angle EAD or angle DAE, would form a linear pair with the angle BAD. That is one way you can do it. The second that would form a linear pair is if I would outline the other side of the angle, the ray AD, and just keep it going for the straight line. So now I see that this angle here in green, angle GAB, would also form a linear pair with angle BAD. So just extend this extra lines, the sides of the, extend the rays to form lines to find the other linear pairs that form with that angle. All right? Oh, sorry, one more. I knew I was missing one more. All right, these are my favorite types of problems because they're little word problems that don't give you numbers. It's all, translating words into math problems. So let's read through it and see some key points here. It says the measure of an angle is twice the measure of its complement. So remember, complementary angles are 2 angles, so I'm just going to put little fill in the blanks here, that should add up to equal 90 degrees, because that's what a complement is. It says find the measure of each angle. Well, we need to figure out what represents both angles. It says the measure of one angle is twice the other. So we know one angle, and then twice the other is represented by 2x. Okay, most people will get the 2x, but you have to remember that complements are 2 angles that add up to equal 90. So our equation is x plus 2x equals 90. So 3x equals 90. And we're going to go ahead and divide both sides by 3, so x equals 30. The question says find the measure of each angle. Well, in the fill in the blanks, we represented each angle here, okay, plugging it back in. So one angle is going to be 30, and the other angle is going to be 2 times 30. Oops. So 30 and 60 are our 2 angle measures. And if you notice, one is twice the measure of the other, okay? All right, so that concludes our 2 sections, 1-4 and 1-5, of measuring angles. What we want to remind you, and we'll tell you in class too, is make sure you have your own compass and straight edge, because the next video lesson will require you to have those 2 items to practice with, which you'll be using in class the following day for an activity. So, hope you enjoyed your lesson.